Okay, today we're going to talk about functions and what they are and what is a relation. So we're going to get into 9.1 and 9.2. This one we're only going to do 9.1. Okay, so we've looked at ordered pairs written as a table, and I just kind of wanted to reiterate that. -4, 0, -4, 0. This is my x and this is my y. So a function is a special kind of relation. So we've been dealing with relations, but we also have been dealing with functions, but we don't really know what they are yet. So there's a couple different definitions in your books, and this is my favorite one. Let's draw here. This one is my favorite because it's the most understandable. It is a set of distinct ordered pairs in which no first component, the first component is x, because that's normally when we write it, we write x, y, so this is our first component, this is our second, is repeated. So x is not repeated for it to be a function. For the relation to be a function. So this whole section, both sections actually, all we have to do is see whether x is repeated. Okay, so let's look at a set of ordered pairs and see whether that they are a function or not. So all we care about is the x. We don't care about the y. So we'll look at the x values. Is one of those values repeated? Yeah, -1 is. So this is not a function. Let's look at the second set of ordered pairs. Let's look at the x values. And look, y is repeated, but I don't care. It's just the x values. There's no value that's in there 2 times. So yes, it's a function. Okay, so let's look at a couple of other things. So we're also going to look at mapping, which is this right here. We'll talk about that in a second. We're going to look at it as a table, a graph, and an equation to see if we can look at all these different things and determine whether it's a function or not. So we looked at a set of ordered pairs. That's really easy. And actually a table is really easy. We'll show you how easy a graph is. Sometimes an equation's not so easy, but we'll conquer that in a minute. So this is what is called a correspondence or a mapping, or some people call it a correspondence map. And so x1 corresponds with y1, x2 with y3, y2, etc. So I'm going to write these because this is my domain, this is my x value, this is my y value. And the subscripts just help us to keep it separated. So x1 is paired with y1, x2 is paired with y2, x sub 3 is paired with y2. Well, I can see y is repeating. x4 is paired with y3. So we're only looking at the x values. Are any of those repeated? No, because they all have different subscripts on them. So yes, this is a function. So let's look at the domain and range, and that's kind of what I was getting at a while ago. The x values are your domain. Just fancy words, we just have to learn the terminology. And it is our independent variable. Because when we plug into an equation, we normally start with x. So x is our independent. And then if we plug in 2, we would get 5. If we plug in 3, we would get 6. So y is dependent upon what we put in for x. So our y value is our dependent variable, and it is our range. And right now, not in this course, we're too worried about independent and dependent. We are worried that you understand the x values are your domain and your y values are your range. Okay, let's get the next slide here. Okay, so let's look at a table. Again, these are our x values, these are our y. So, what is our domain? It's 0, 1. It contains all the x values. Our y values, our range, is 0, $3.50, $7, $10.50, and $14. Is it a function? Well, let's look at our domain. We only care about that. Is there a number, is there a value for x that's repeated? No. So yes, it's a function. All right, let's look at the next slide. All right, so now let's look at a graph. Is it a function? Well, let's not talk about a function. Let's do the domain and range first, and we'll talk about one of those in a minute. Okay, so let's look at the domain. What can the x values be when I look at the whole graph? And this is just like a little section of the graph. So it goes on forever and ever. You can see that our line goes on and 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 on. So if I kept going on and on and on and on and forever, you can see my x values go on. There's a value for x way over here because it's way down here. There's an x value way over here. There's an x value way over here because this line would be way down here. So our domain goes from negative infinity to positive infinity. What is our range? What are the values that y can be in this relation? Well, y stops right here. It doesn't go any higher. It doesn't go any further up there. It stops at 4, and it includes 4. And then you can see these values go down, down, down. So way down here, I would have a y value. So it goes to negative infinity. So when we write that, we always write our interval notation with the smallest number. So negative infinity, it stops at 4. So our range is our y values. It goes from 4 all the way down to negative infinity. We always put a parenthesis, and it does include 4. It stops right there. We'll talk about in a minute whether this is a function or not. An easy way to tell by a graph if it's a function or not is by the vertical line test. We should be able to draw a vertical line anywhere on that graph or anywhere on that coordinate plane, and if it touches the graph more than once, it's not a function. So it can only touch it one place. One touch, it's a function. Two touch, not a function. Well, let's see why that makes sense. So here's my coordinate plane. Here's my graph. When I drew the vertical line test here, it touched here and here. Well, this point's about negative 1, 1. This point's about negative 1, negative 1. You can see that my x value is repeated. And it would happen the same thing over here. If I drew it here, it would do here and here. So maybe this is 1, 2. This would be 3, negative 2. And this might be 3, 2. You can see that x repeats. So no, this is not a function. Here, if I drew my vertical line test, it only touches once. There's only one x value here, which is about, I don't know, 1, 2, maybe 2-ish. So 2, 1. And that's the only time that this function has that x value. So yes, this is a function. All right, let's look at these graphs. So this is actually a parabola, which we'll study later on in the semester. If I drew my vertical line right here, it only touches once. So yes, it's a function. Here is a circle. No circle ever is never a function, because if I drew it right here, it touches it here and here. So my x value is 1, 3, and negative 3, and my value here is 1, 3, and you can see x repeats itself. So no, this is not a function. So it's really easy. You can just draw a vertical line anywhere and see if it hits that graph twice. If it doesn't, then it's not a function. So let's look at this one. Is it a function? Well, if I drew a line here, here, and here, it touches it twice. So no, it's not a function. I could test it again, right? This one's really kind of funny, but we'll leave that one alone for right now. So it's not. These two already tell me it's not because they've got multiple values that are repeated. What is the domain? What are my x values? If I look along the x-axis, this graph does not go past -2. Don't have any values over here. So I know it includes -2, and then this line goes forever and ever, ever to the right. So it would be positive infinity. My range, what can the y values be? So this goes all the way up. There's values all the way, way up here, so it's going to have y. And here it goes down. It continues to go down, down. So this one has negative infinity to positive infinity. All right, so let's graph this and determine whether it's a function or not. So we know how to graph now. This is a +0, so our intercept is 0, 0. This is what we did in chapter 3. My slope is -3/1, so I'll go down 3 and to the right 1, down 1, 2, 3 and to the right 1, or I can go +3 and to the left 1, 1, 2, 3 over. And my line looks something like that. Is it a function? Sure, it's a function, because if I drew my vertical line test anywhere, it would not hit the graph more than one place. So yes, it's a function. So when doubt, when you do equations, sometimes it's easier just to graph it, and then you can tell by the vertical line test. What is the domain? -infinity to positive infinity. It goes this way and this way forever. And my range, it goes up this way and down this way forever. And basically all lines, straight lines, all lines except vertical lines, are functions. If I drew a horizontal line, and I did my vertical line test, yes, this is a function. If I did my vertical line, and I drew a vertical line, this would be not a function. So this is the only one out of straight lines that are not a function. Okay, we will continue 9.2 in the next video.